Hello and welcome to this video. We're going to go over the last measure of central tendency that is called the median. The median is, as we usually know it, the value that splits in half a set of data that we are given. We call this a bottom and a top half. And in general, we are used to this initial definition. That is, if we have a set of n ordered values, the median is found at the value that is at position n plus 1 over 2. So in general, we need to work on that. I'm going to use this first example. We're going to see two examples here for how to work with this. And we're going to use things that we already know. We're going to use the stem and leaf diagram. And we're going to use the cumulative frequency. So if you don't recall this, or if you're not sure about this, take a minute to go back to the videos that we have on that, or to the web page where you can find information on how to understand the things, and then go back to the median and see how we can do this. So now, yes, if you're ready, let's begin with this first exercise that we have here. We have a do-it-yourself store that is open for 12 hours on Monday and 15 hours on Saturday. The number of customers is given in a back-to-back stem and leaf diagram, and this is very useful because this tells you information that is already ordered from the least to the highest value. So the stem and leaf diagrams are very useful when finding median, and this is a very typical exercise for the A levels. So for example, let's say here that we have, as usual, you have to read the key. The key tells you that 022 represents 20 customers on Monday. So remember that we leave from the center to the left for Monday, and then we have 22 in the Saturday from center to right. And here I'm giving you, just as a matter of convenience, the number of data that we have here. Remember this is 12 hours and 15 hours for the Saturday. So how can we find the median here? Well, if you have 12 pieces of data, you're going to do 12 plus 1 over 2. This is going to be 13. 13 over 2 this will give you 6.5. What does 6.5 means? It means that we need to take the average between values 6 and 7. So we're going to be doing 1, 2, 3, 4, 5, 6. This is value number 6. I'm going to write it down. This one, that is a 28. And then 7 is this one. So this is a 30. What are we going to do with this? We're going to go and say, okay, we add them up, we divide over 2, and the median for the Monday is a 29. That means that in half the hours of the Monday, there were more than 29 clients, and in half the hours of the Monday, there were less than 29 clients. This is like how to understand the median in this exercise. What happens in Saturday? Well, in Saturdays, we're going to be doing the same. We're going to start with the value for n, that is 15. 15 plus 1, I skipped myself, plus 1 over 2. 15 plus 1 over 2, that gives us a beautiful 16 over 2, that is 8. So we must count the 8th value. We're going to be doing again, this is going to be 1, 2, 3, 4, 5, 6, 7, 8. This is the 8th value, that is a 38. So the median for the Saturday is just 38. As this was an exact value, we don't need to do anything else. So this is, for example, how we can work with the median and with the stem and leaf diagram. What else can we do with the median? We are going to be working with cumulative frequency, because cumulative frequency will help us when we have readings. Like, for example, here we have grouped readings of X. We have 40, ungrouped, we have 40, 41, 42, 43, 44, and their corresponding frequencies. So how can we work with this? We're going to work with the cumulative frequency. How does cumulative frequency work? If you don't remember, you can go back to the cumulative frequency video or to the web page. But in general, what we're going to be doing is we're going to be adding values of the frequencies from that point and above. So in this case, this would be just 11. Then we're going to be adding 23 plus 11. This would be 34. Then we add 19 plus 34. This would be 53. 53 plus 8, 61, and then 65. Again, we show that the total is the last value on the cumulative frequency. Now, think about the median. The median is at the value n plus 1 over 2. So you're going to be doing 65 plus 1 over 2. This is going to be 66. 66 over 2 is 33. So the question is, which is the value at the 33rd position? Well, we know from the cumulative frequency graph that, from the cumulative frequency table, that the first 11 values are 40s. It's going to be 40, 40, 40, 40, 40, and so on and so on. Now, from the 12th up to the 34th value is going to be all 41s. That means that the 33rd value is a 41. Hence, the median is 41, because the value is going to be at the 33rd position. So this is something that we can do when knowing the frequency. When knowing the frequencies, we can go to the value, the n plus 1 over 2 value, and look up the first value that is greater than the value that we're looking for, and that would be the value for the median. Finally, the last thing we're going to be doing with the median is we're going to be estimating it via graphs. So in this case, we have a beautiful cumulative frequency graph, a cumulative frequency curve, and in this case, as data is given like this, we don't necessarily need the n plus 1 over 2, because it's a very slight difference in this case, so we can just use the n over 2 volume. And take a look at this. We have 300 museum artifacts. They are represented in this graph, and what we want to do is we want to find the median. Well, what are we going to do? We're going to go to the graph here, and we're going to look at the 150. Why the 150? Well, because it's half of 300. If 300 is total, the half is going to be over here. We go to the graph and we find the mass somewhat around 2.6. So we can then say that we can fairly assume that this is going to be our median around 2.6 just by looking at the graph. As usual, we're going to finish this video with advantages and disadvantages for the median. We can find it without knowing all the values. This is something that is useful for someone that is making an investigation, because knowing some part of the data, you can still get a number. And it is, in general, unaffected by extreme values. It's something that's very useful when making some predictions. But as usual, we have to have data to be ordered, and we are ignoring most of the data in it, so it may not be as representative. That depends on how you combine it. But here we have this. This is the end of this video, where we have covered the last measure of central tendency. I'm going to be making another video. It's going to be at the beginning, so we're going to begin discussing some ideas on skewness. So check that video as well. I believe that's going to be quite short. And as usual, if you have any questions, please leave them on the comment section, and take a look at the exercises in the webpage in case you need to see more about it. Thank you for watching.